Next up, we actually have Mark Schmarny, who's going to be talking about identity management in distributed applications using Dapper. As I mentioned before, you can always find information about the, oops, sorry, my screen's share here. You can always find information about the of all these sessions at ACA-MS, the Launch Space Kubernetes. And I see Mark's here. Thanks for joining, Mark. And welcome to the session. Please take it away.
All right. So my name is Mark Schmarny. I'm one of the product managers working on Azure here at Microsoft. And so far, if you follow the day of our TV learning here, a lot of the things been focused around the infrastructure and kind of operational side of things. I want to make a slight switch and kind of focus a little more on the developer side of the developer experience and building applications. So I'm going to share today about Dapper, specifically as far as building applications or microservices with Dapper, and then using identity for the different microservices to manage the access control and the different things that the applications can do. All right, so let's jump into this. A very quick intro in case you're not familiar with Dapper. It's hard to kind of reduce an entire project to a single sentence, but it's a portable event-driven runtime for building distributed applications. Portable, we're going to talk about a fair amount of that. There's a lot of content already online about it. It's a project that was created by Microsoft about a year ago and open sourced. Since then has grown pretty quickly. There's close to 10 million image pools every month. There is also about 450 or more than 450 different contributors from a broad number of different companies. So if you want to learn more about Dapper itself, Dapr.io is a good place to start. Let's go very quickly into kind of the logical layers of what make Dapper in a form of introduction into the project. Dapper is kind of agnostic with regards to the language you're using, so polyglot, meaning that you can bring whatever language you're already developing and you're familiar with, whether it's JavaScript, Python, C#, Go, Java, Rust, or whatever else you want to bring in there, and use that language to kind of accelerate or speed up how quickly you develop different services and kind of make sure that you can use the best practices that are available for that particular architecture. What Dapper does is creates this runtime that you can execute. It runs on any application, on any kind of platform that you want to deploy to. So obviously runs on top of Kubernetes, which we are focused on today, but it also runs on your laptop during the development. It can run on a bare metal VMs, as well as an edge devices, all the way down to Raspberry Pi even. Because it's a framework, Dapper exposes these two sets of APIs. That API have parity between them, so there's no difference of features, but they're exposed through different protocols. So we have an HTTP API and gRPC API, and depending on which language is more, what's your comfort level with different one of those languages and these protocols, you can leverage them in different applications. And you can mix and match, for example, if you're building a microservice application that includes 3 different microservices. One of them could be in gRPC, another one would be HTTP, and Dapper can actually help you with a lot of the translation between communication across those. So let's, the part that I want to spend a little more time about is talking about the building blocks or these kind of middle layer in here, because I think this is what really distinguishes Dapper from a lot of other runtimes or frameworks or platforms out there. If you've developed applications over the last, let's say, 10 years in modern cloud native applications, you probably have noticed that a lot of the patterns that you're using to build those applications are very reproducible. Every one of your applications has some notion of a service invocation or PubSub. So what Dapper does is kind of codifies these best practices or the common practices and makes them reusable in a form of a building block, so your application can actually externalize these dependencies outside of its code and focus only on a business logic, which makes you much more effective, allows you to swap these components a lot easier, and obviously increases the overall portability of an application because you're not bound to specific implementation. These building blocks or these common patterns are just a facade or APIs that are exposed by Dapper, but the actual implementation behind them can be done through a number of different solutions out there. I'm going to talk about this in a minute. So let's very quickly go through each one of those. For service-to-service invocation, which is basically if you're building an application that includes multiple microservices, you're going to have to be able to discover these services and invoke each other. from each one of those services. Dapper provides a service discovery. It provides a mechanism for invocation regardless of the protocol that you're supporting, as well as kind of allows you to obfuscate the kind of location and number of instances that this application runs. The invoking application only needs to know the ID of the application. There's a fair amount of sugar that Dapper adds on top of that around retries and commonality of error controls across different protocols, and throttling, for example, that allows you to kind of focus, again, purely on the development. Now, if you're building microservices and you're thinking that direct service invocation is actually anti-pattern and you don't want to do that, Dapper provides a synchronous pattern for PubSub that allows your applications to, or different microservices in your application, to communicate asynchronously using messages. So what that means is that the publishing application doesn't need to know anything about the backing application, the subscribing application or consuming application, and vice versa. And that kind of increases the overall decoupling and flexibility of the overall application, allows you to, again, focus only on writing the business logic that you need to do. So for service invocation, for example, for PubSub, for example, there is 10 plus different implementations or different component implementations you can use, whether it's something like a Kafka, RabbitMQ, NATS, also a managed services like Event Hub on Azure. After that, if you're writing anything nowadays, you're pretty much going to have a durable state, meaning that as the session of the user expires and the user comes back again, you don't want that user to be just treated as every single time as a new request. So Dapper, kind of in microservice world, the idea of saving that state to their local disk would be a very much no-no. So Dapper provides a kind of a distributed state management, which means that you can rely on this key value stored to be durable. Means your services can, even if they're restarted, they can come back and retrieve the state. We provide implementation for state building block like Mongo, Redis, Postgres, as well as something managed like Cosmos DB on Azure. Next one, if you're building applications and kind of have dependency on different external resources, or even storing anything sensitive, you're going to need to manage secrets. And managing secrets in a distributed dynamic application tends to be very complex, and that's why we see front page announcements all the time about yet another set of secrets that have been leaked either by committing to GitHub repository or by somebody accessing incorrectly. What Dapper does, it tries to kind of generalize the way you consume secrets, both inside of the user code, as well as inside of the configuration that you describe your application with, and provide a pluggable mechanism by which the different implementation for where you manage the secrets can be pluggable. So obviously, HashiCorp Vault, Kubernetes secrets natively if you're running inside of Kubernetes, but as well as managed services like Azure Key Vault. You can do those without changing the actual application, because again, the application just consumes the very common and standardized set of APIs. Now, these four first patterns being very generic, and you kind of had a very common way of dealing with these things. The implementations are totally different, but the actual way you consume those are pretty common. But eventually you get to the point where you need to consume something that's very specialized and external. And we call those resource binding, and provide an interface inside of Dapper that allows you to interact with those external resources, even though they're very specific. So something like a Twitter API or Twilio API or Kafka or whatever that may be, but still have a consistent way of assuring the configuration of those resources and defining of secrets inside of those resources, or even tracing around and logging around the access to those resources. So resource binding allows you both interact with resources that you want to invoke from your application, which we call those outbound bindings, as well as inbound binding, which trigger your code, for example, based on external event. Let's say tweet was published, you want to consume that. You write a logic that only is responsible for processing the tweets. All the binding of those resources to your application is done automatically by Dapper. Now, because of the way that Dapper is implemented, and we're going to talk about this a little more, Dapper has a full knowledge of the entire knowledge graph or the call graph that it's implemented in your application, which means that it can provide a very detailed observability around both the logs and metrics that you normally would do, but also as well as traces. And that means that without creating any special spans inside of your application, whatever code you're using, you can actually get a visibility around the invocation and the duration of the invocations and counts and so forth. It's a very powerful feature that's automatically enabled inside of Dapper, and you don't have to do anything inside of your code. Again, the focus is on helping you writing the logic that actually makes your application unique. And then finally, we have actor model. If you've kind of followed either the Orleans framework from Microsoft or akka, you're kind of might be familiar with the concept of actors. Dapper generalizes that concept to the point where the logic and the state is actually combined together. It's a single threaded model for allowing your application to kind of define a specific functionality. It's very common in IoT devices or something like that. It is single threaded, so if you're looking for a high IOPS, that's probably not the solution because it's going to be locking. But there's a lot of use cases where that kind of approach works, and you can gain a high density of workloads, thousands and thousands of actors in something that normally would have been just one pod. So that's basically Dapper at its high summary. Let's go a little deeper. So when you start using Dapper, and we're going to talk how that kind of is accomplished, you're kind of creating a virtual API, a sidecar that sits next to you, whether you're running on a local machine or whether you're running on Kubernetes. I know Kubernetes has this construct of a sidecar. We kind of using that same exact approach, whether you're running a local machine during the development or on the edge devices or on a bare metal, because what Dapper does, it creates this sidecar and kind of sits next to you and provides you that API. And like I said, that API exposes this consistent way of invoking all the other resources. We talked about state and PubSub and binding, but also what Dapper does is when you start invoking another service within your application, it provides a secure communication using MTLS across those automatically. So your application doesn't do any secret management, doesn't do any certificate management. It just focuses again on the actual logic. So how do you get that magic sidecar we just talked about? Well, first of all, during the development, you rather than launching your normal application in the pattern that you already do, so let's say Node app.js or something like that, you're launching it using Dapper. So Dapper run, there's a few additional parameters you have to provide, like the name of the application you want to use that's going to be known by all other applications, the protocol you're going to be using, a couple other configurations around the components that you're going to be using. That configuration is specific to that one instance of the application, which means that in a single application, you can use some components that are specific to that, in another one for another. Now, I wasn't going to list all the examples, but the exact same thing you can do in Python. Eventually, you can actually compile your application running as an executable, whether it's a Windows executable or Mac or Linux. It really doesn't matter, whatever platform you can run. Dapper compiles into obviously the three different platforms, Mac, Linux, and Windows, but it also compiles into ARM and AMD architectures. We're working on, whenever somebody requests a new one, we keep adding that. There's probably 8 or different distributables at this point. Now in Kubernetes, what we want to make sure is that this is very idiomatic, meaning if you're already building application on Kubernetes, you're already familiar with deployment. Deployment is a unit of kind of workload definition for your application. What we do in this case, we actually just using the annotations to allow you to define additional parameters. The very same parameters you were using to launch your application using Dapper run, you can define them as annotation attributes, and those are just launched with your application that allow your application now to create that sidecar inside of Kubernetes and get the exact same API that you had on your local machine. Different mechanism, exact same API, exactly everything works exactly the same. All right, so this was kind of super quick overview of Dapper. There is a full-blown webinar we've done recently that goes through each one of those much more in depth. I encourage you to take a look at that. So let's go into the microservices. I talked about this little as part of the initial invocation, but I want to go a little deeper into this. So if you have something like a front application that using the card application on the back end, and your front application is developing HTTP or exposes HTTP protocol, and the backend card application uses gRPC, what you can actually do is not really even worry about it. What Dapper allows you to do is just use that same exact consistent API, invoke that application. In this case, we're calling the invoke card, and then specify which method you want to invoke on the other service. And Dapper will translate that protocol, invoke that service, take the information, and send it back all the way back. So front to back, dealing with the entire discovery invocation. When, for example, the card application would be overloaded or something didn't work, the retry would be automatically handled. It's configurable how you do it. The throttling between the invocations, as well as error translation. For example, you've thrown a gRPC error, the error was translated and communicated back to the front end using HTTP. Because Dapper is so easy, day 2 or day N, you start having these number of different applications that are all over the place because it was so easy to build those microservices. So how do you create a kind of mechanism to make sure that these services are able to talk only to the right set of services? If you're deploying into like a soft multi-tenant environment, let's say inside of your company, maybe using namespaces or maybe crossing namespaces inside of Kubernetes. So how do you kind of enable this to be much more declarative and controlled so that you have guarantees around who can access your application at any given time? So we talked about this fact that Dapper has this notion of a sidecar. These applications are defined by their ID. So we have app1, app2. We talked about the fact that Dapper uses MTLS automatically to communicate between those. What we actually do inside of, in addition to that, is Dapper is leveraging a SPIFFE specification or protocol that identifies that kind of defines the identity of the application in a URI format. And what that means is that we have that SPIFFE identity as a unique identifier for the application that's combined with the trust domain within which that ID was defined. And Dapper used that identity to then kind of identify the applications, both the calling from as well as the invocation policy for when that application is being called. That identity is actually encoded into the TLS certificate. So you have no new kind of way of that you have to look into, but the Dapper automatically packages that certificate the SPIFFE ID into the TL certificate and decodes it on the other end, so that policy can be simple and plain to write. SPIFFE is quickly growing in popularity. So you've heard already the Open Mesh presentation before this one talked about integrating this in the future. So hopefully we'll have much deeper way of communicating between different projects that it's agnostic to the specific technologies that we're using. So now when you come into Dapper, using the SPIFFE identity, you have a deep knowledge of the application 1 being invoking application 2. You can use access policies to control how this who the application is and which type of functionality that invocation can be performed on, because it's all done inside of a trust domain. All right, so let's talk quickly about demo. It's usually good to, when we talk about this abstract technologies, to provide some real world example. This is pretty fully functional application. I'm going to share a link later to a place where you can fully reproduce the entire thing. There's no magic in here. You go in and you follow the steps to reproduce the entire application. But what we're going to do is a simple application that exposes a count API that can be invoked externally. It also persists the state across the invocation. So if you come back, that count obviously increments, and also does some back processing using invocation using PubSub that allows the application number 3 to process the submitted events. It has secrets. The components are defined in a different namespace. It has external ingress. So what are we going to do during this demo? Because there's going to be a lot of moving parts. So let's kind of go through this quickly. First of all, we're going to Dapperdize the ingress itself. So allow the ingress, in this case NGNX, to be able to be part of the larger solution for inside of Dapper. So we'll have its own identity, and we can trace the information that are the calls that are being invoked on the ingress. The ingress is going to expose a SSL endpoint. What we're also going to do is internally, we're going to define this trust domain that allows us to kind of treat these 3 applications that are kind of individual as one unit and make sure that they can talk to each other at any given time. We're going to make sure that these 2 applications that actually need to have an access to secrets are the only 2 applications that can access secrets, and only that one specific secret that they depend on, the Redis secret. We're also going to make sure that the state component is only accessible from application number 2, and that a PubSub is accessible from application 2 and 3, and that application 2 can only publish and application 3 can only subscribe. So very hardened kind of environment that tightly define only the things that can be done First of all, it says nothing can be done, and then explicitly define what can be done. So enough of slides. Let's do actual demo in here. So for that, what I'm going to do before we get to command line, I'm going to quickly go through VS Code in here and just show the deployment. So let's see if I can make this a little bigger. At some point, this is going to be too big. But what we have here is the actual deployment. You should be able to follow this. Again, a few annotations in here. We defined that, yes, please give us the sidecar from Dapper, application number 1, all the other configurations. But one of the things in here is we're defining is that the configuration for the application is actually going to be managed in this configuration object. So let's focus on that. A couple things in here. We say that we're going to have, would like to have a sampling rate for our tracing application, 100%. This is a number between 1 and 0. So 1 means actually everything. Every single code is going to be traced. We're going to say that we want to deny for this first application who doesn't need to have any access to Kubernetes. We're going to say denied everything. No, this application should not have access to any secrets. We're also going to say that this application is going to be part of a trace domain. We're going to deny every invocation except the nginx ingress, who itself is going to be denied everything except this one method called ping, which only can be invoked over post. And that's the only one we're going to allow. I'm not going to go through this one by one, but in application number 2, you will see exactly the same thing, saying we're going to allow only access to one secrets. We're going to allow only invocation on the counter over post. The one thing I want to do focus on is these components that we've defined before. They're very generic. So you've seen us talking about the PubSub component. In this case, we're using a Redis PubSub component that has secrets. So obviously, we're using the connection string and passwords in here. But the one thing I want to talk about is that to define these complex policy that allows only these 2 applications to be able to use this component, you simply define the scope for that component that can be only accessed from application 2 and 3. You can't make policies any simpler than this. Similarly, for publishing, to limit which application can publish to a topic and which can subscribe, similarly, you do the exact same thing in here. So let's quickly go to our console in here, and I'm going to now that we have this deploy. I've deployed this entire stack before because it actually takes a minute to deploy it. But what I want to do is actually demonstrate. Hopefully you can see this. What we're going to be doing is simple curl command against the external HTTPS endpoint that we're going to be invoking the application number 1 with a simple ping request. For demo purposes, this application doesn't have to be any more complex. So when we do that, the entire call stack was traversed, and everything we wanted, we got back from this. There is a count. You can see I've been doing a lot of these demos. That's returned. Now, what I want to do next, though, is show you what would happen if I, for example, try to access. Oops, wrong one. Cut and paste skills are weak. Okay, what I want to do is access now the second application externally, which we know we've kind of prevented this from happening. What Dapper will do automatically is recognize that the policy is not allowing for that to happen. It will send you pretty detailed error, but actually the HTTP 403 is all we need to know. We've been preventing to access. Now, you might be saying, hold on a second. You've just shown me an external ingress. Why would I want to do that? Maybe I don't expose my application this way. So what we're going to do now is I'm actually going to forward local ports to the second application. And because now we are kind of inside of the cluster, I want to show you here what would happen if I actually use the invocation, exact same invocation from the application number 2 upstream to application number 1, which clearly is not part of what we enable. You would get exactly same error because the context of the invocation is not it's not physical layer, it's how you got there, but the actual real identity of that application. That exact same principle doesn't work only for service invocation. Here, we're going to try to publish to a topic that wasn't part of our policy. Again, from inside of application 2. Application number 2 is actually allowed to publish to PubSub, but it can only publish to this one message called count. So test doesn't get. We get the error saying that you're not allowed to publish to this one. It works exactly same way for secrets and all the other APIs that Dapper exposed. So in kind of retrospect, you've seen this. It's a pretty, while the logic of the application is pretty simplistic, we're doing simple counts, it kind of is representative of what you would see real life. You have a state, you have PubSub, you have secrets, you have invocation from outside for only one service. So for example, directly invoking to application 2 or 3 was prevented. So it should be pretty real. And here's the link, Dapper demos, and aka.ms, you should be able to go in and follow those steps to reproduce the entire demo, including compiling your own images for this application. So in closing, Dapr.io is the single place. If you forgot everything else about the presentation I've given today, is the place to go. The actual project itself is on GitHub and under MIT license. It's all open source. You can take a look at it, github.com/Dapr. There is a pretty robust community of different areas of the interest around Dapper on Discord that you can access. Twitter, Dapper Dev, and there's a bunch of videos that kind of go in depth into specific areas or components or the ways of dealing with deployments in different environments. If you can't find anything else, mchmarney@microsoft.com is how you can get hold of me, and I will connect you with the right people. Hopefully those were helpful.
Very helpful. Thank you. I just want to say I have posted some of those links in the chat as well, so you can access them right now. Otherwise, you can always go to our page, which is aka.ms/launchspace Kubernetes. If you share my screen here, I can show you a couple of those different things that that you've just highlighted, actually. So Mark's sessions here, I've got a couple of links, the Dapper site and the demos on GitHub. So the Dapper site is here. It's Dapr.io, as Mark mentioned. And you can see the actual repo with his demos as well on GitHub at the link in the chat. All right, so that concludes. Thank you very much, Mark. That was wonderful. I do have a few questions for you, actually, before we go. A couple of questions. You mentioned before, different languages that Dapper supports. What about frameworks that Dapper supports, like Spring Boot or .NET?
Absolutely, yeah. Dapper has, in addition to these very raw protocols like HTTP and gRPC, it has actually a set of SDKs that you can use to interact directly with that obfuscate the protocol plumbing and so forth that are available in C# and Java, Python, Node.js, Go, as well as integrations with framework. Like you mentioned, Spring Boot, for example, has a nice integration for Dapper, as well as .NET itself. And there's a working project on a Python integration into some of the frameworks there too. So much deeper than just language itself, actually providing integration into the kind of plumbing of the framework itself.
Absolutely. Great. Thanks. Hey, we got a couple of questions from attendees as well. Oops. Yeah, sorry. The first one is, what are the components and configuration for Dapper?
So Dapper,
yeah, go ahead. Sorry.
Yeah, when Dapper has some primitive set of objects. It really, inside of Kubernetes itself, it depends on the deployment for the deployment, which is the native Kubernetes object. But in addition, when you install Dapper into the cluster, it configures 2 additional or 3 additional objects in there, 2 additional CRDs with few objects. The configuration itself, it has additional ones around kind of the actors and a few other ones. But pretty much that's all it is, pretty light on the integration and kind of tries to use whenever possible the native objects inside of Kubernetes.
Okay, well, great, thanks. A little more involved question. In case of SPIFFE identity, what will the context of the SSL with regard to, I believe, domain name and ID? So let me ask that again. So SPIFFE identity, what's the context of SSL with regard to domain name and ID? There's a couple spelling errors there. I blessed them.
Yeah, I would have typed it just as bad. So Dapper kind of automates the generation of the SPIFFE ID. So we'll use in case of Kubernetes, it will use the namespace plus the trust group that you've defined to create the identity of that particular application. So it's kind of almost guaranteed to be unique. If you're deploying Dapper outside of Kubernetes, you can actually specify a fully qualified domain or the domain that you want to use for that custom certificate. Dapper also supports your own certificate. So you can, instead of relying on Dapper to generate the MTLS certificates, you can bring your own certificates, and Dapper can use those, including integration with service meshes. Obviously, you would have to disable MTLS because that encryption would be provided by the mesh itself, but can work inside of Istio or Open Service Mesh or any other kind of integrations there.
Wonderful, thanks. Last but not least, is Dapper under open governance? I know we mentioned policies a bit, but yeah. Yes,
we actually publicly announced our path to get there. I don't have a timeline at this point. There's a blog post. I will include a link here in a minute where we've talked about this. It's very much the next step. I think we are preoccupied right now with the 1.0 release that's going to be landing pretty soon. We are on a milestone 2 in a couple weeks, I think, or next week. The release candidate number 2. And once the 1.0 is out of the door, I think that's going to be pretty much the first thing we're going to be focusing on. So stay tuned. But we've publicly acknowledged that that's what we want to do. Despite the governance, there is already a pretty broad kind of external number of contributors. They're kind of contributing not only the code, but also to the direction of the project. So many of the kind of hygiene of an open governance, we already kind of are following those principles to make sure that this is ingrained into the project itself. Great, right.
Well, thank you very much. Thanks for your time today, Mark. That was wonderful. And that is the last session in our show today. So thanks everybody for attending. Just before we go, I do want to share the screen one more time just to show the links that you need. So we covered Brendan Burns. We talked about Kubernetes innovation. We talked about the recent announcements with AKS. We covered Azure Arc, some info on Azure Stack HCI as well. We checked out Open Service Mesh with Philip Gibson, and we've wrapped up with identity management using Dapper. So we will have sessions that had a few streaming issues rebroadcast a little bit later. But for now, I just want to say thanks to everyone for coming. And for more information, go to https://aka-ms launch space Kubernetes. That takes you to a GitHub page, which has all the information here. When we have videos ready, we'll be posting them there. You can also find them on the YouTube Microsoft Developer channel. Just search YouTube Microsoft Developer, and you'll find that. And thanks for joining this Learn TV show. It's been great hosting, and hopefully it was useful information. And please do get back to us with any feedback. Thank you.